So this lesson is about rotations, and these are rotations are trickier for a lot of reasons than translations. With rotations, and I'm having a hard time with the paper here, you're going to hold one point in place, and then you're going to turn your shape around that center. And the center might be on the shape, the center might be in the middle of the shape, or even the center rotation might be outside the shape. So you've got it like sitting on a turntable and it's spinning around that central point. So to perform a rotation, you're going to need to know two things. First, you're going to need to know where that center is. So that'll be a point. I usually will call that you rotate it around that point. And then the other thing you need to know is you're going to need to know how far to turn it. And that's going to be a number of degrees. And I will usually say so many degrees either clockwise, which goes the way the clock goes, or so many degrees counterclockwise, which goes the other way, the way against which the clock goes. So those are the two things you need to know for rotation. So let me show you a couple of examples. These are a lot more work than translations are. Here's the first. I'm going to start with the triangle here. And I'm going to label this point down here P. And I'm going to rotate the triangle 90 degrees clockwise. I will abbreviate clockwise with CW around point P. So when I say around point P, again, that's the center. The center is the fixed point around which the figure turns. Point B won't move at all. So the image of point P, P prime, is going to be the same as point P. It's just going to stay right there. Then the triangle is going to turn 90 degrees clockwise around that point P. So it's going to turn like that, 90 degrees. So if you picture like the segment that's straight up vertical, it's going to turn from 12 o'clock to 3 o'clock. So let's see how we do this by hand. So I'm going to turn this point A. So I'm effectively going to turn that segment PA 90 degrees clockwise. So what I need to know is I need to know how long is that segment? How far is that point P from A? How far is it from A to the center? So I get my ruler. And what does it look like here? 32 millimeters. It's hard to read. 32 millimeters. So from P to A is 32 millimeters. So for my right angle, I'm going to use this triangle here. So there's a right angle in this triangle. So I'm going to turn 90 degrees clockwise. I'm going to turn by that 90 degree angle right there. So I line up one edge of that angle. I put the corner of the angle, the vertex, at the center. These are very difficult to handle by hand, these pieces of paper. So one edge is along P to A, and then I'm going to turn A through that 90 degree angle, and it's going to land over here. And I have to make sure the distance is correct. I have to make sure it's 32 millimeters away from the center, because if you turn it around P, it doesn't change its distance from P. So to get my ruler out here and measure 32 millimeters from P. So that looks pretty good. Yep. So point A prime is right there. That's where I've turned A to. So I've turned A 90 degrees around point P. Now I have to do B over here because it takes I have to turn the 3 points. Remember that point P doesn't go anywhere. Point P stays right where it is because that's the center. So again, I'll measure P to B because I need that distance. So that looks like, what is it, 45 millimeters? And then I'll get my right angle, put the corner at P, and now I'm going to turn B through that same 90 degree angle. B is going to come around like so to there. So I have to measure 45 millimeters again, because it's got to stay the same distance from P. As it turns in a circle around, it maintains the same distance. So I lay this out, and I see 45 millimeters is around there. So that'll be my point B prime. And as I already said, P prime is actually the same as P. P doesn't move, so the image of P is the same as P. So then I have P prime, and I have A prime, and I have B prime. And so now I can connect the dots like they were before, and I get my rotated triangle. Like that. Ta-da! And there my triangle has been turned through a 90-degree angle clockwise around P. Okay, let's look at a trickier one where the center point is not at a corner of the shape. It's not at a vertex. So I'm going to draw something that's intended to be a rectangle. It's rather sloppy, actually. There it is. And I'm going to put my center out here. So there's my point P. So I'm going to rotate 30 degrees counterclockwise. So that's going against the way the clock goes. And the center is going to be that point P. So I'm going to turn that rectangle 30 degrees counterclockwise. So that's going to be, turning it around that many degrees. It's not very far. 30 degrees is a 12th of the clock. It's like the amount of degrees when an hour hand goes from like 12 o'clock to 1 o'clock. So now there's 4 points that determine this rectangle, the 4 vertices of the rectangle. So I need to turn all 4 of those. Up here, so there I had P to A, P to B. So now I've got P to A, P to B, P to C, P to D. All those 4 distances. And I'm going to need all 4 of those. So right here at the beginning, I'm going to measure the distance from P to A. Remember, when you rotate A, the distance from P stays the same. So I need to know what that distance is so I can keep it the same. So I'm going to take some time here and measure reasonably carefully how far is each of my points from the center of rotation, because that distance as you turn it stays the same. So let me take the measurements here. PA is 24 millimeters, PB is 53 millimeters, PC looks to be 51 millimeters, and PD looks like 16. So I'll just make a note of those. So for my 30-degree angle that I'm going to turn, I've got another triangle here with a 30-degree angle in it. So I struggle here to get a hold of this triangle. In case you haven't figured, I'm recording the audio after I record the video. I'm still working out some technical details. So I do a little bit of editing here as I fumble around with this triangle here. But the idea here is we're going to lay one side of the angle. Remember, the corner goes at P. And then we're going to measure the 24 millimeters, because that's how far A was from P, and that's A prime. So you can see A here is turned through that 30-degree angle to come down to be A prime. So now we're going to put it along PB. There I've laid one side of the angle from P to B, and then the other side of the angle is going to be PB prime. So I have to measure the 53 millimeters that it is from P to B. So that point will be right around there. This ends up being a little bit sloppy. And if you're concerned, like, oh, my pictures aren't perfect, where this is not a drafting class, we're not doing engineering here. I'm looking to see that you have the correct ideas for these rotations. And as long as you're conveying that you understand the idea behind the rotations, if there's a little bit of sloppiness in your drawings at the end, it's like, oh, this distance doesn't look quite right, I'm not going to be concerned as long as you're conveying the idea. So I rotated PC I rotated C around to get C prime, and now I'm measuring the distance from P to D prime, which should be 16 millimeters. So now I have A prime and B prime and B prime and C prime. And now I just need to connect the dots to get my rotated rectangle. There's A, B, C, D. So I go A prime to B prime to C prime to D prime. Not sure where B prime was. I think I messed up there a little bit. But connect the dots. And there's my rotated rectangle. My rectangle has turned 30 degrees counterclockwise around that center point P. Yeah, it's a little sloppy.